This is 8.1c, Simplify Variable Expressions with Roots, and this is from OpenStax Intermediate Algebra. So we've talked about how to simplify roots, square roots and cube roots and higher roots, but now we're going to be simplifying expressions, right? An expression can be just a number, but it can also be a variable or a combination of variables and constants. And so let's go ahead and dive right in. So the odd root of a number can be either positive or negative. Okay, so you need to pay attention to whether you're talking about an odd root or an even root. Okay, so a square root would be even because you're taking the square, and a square is 2, right? But a cube root is 3. That would be odd. So if we're doing this in root notation, a square root, that would be an even root, but a cube root would be an odd root. A fourth root would be an even root. A fifth root would be an odd root. Okay, so that's what we're talking about when we're talking about even roots and odd roots. So the odd root of a number can be either positive or negative. Let's see why. If we have the cube root of 4 cubed, that would be the cube root of 64. 4 times 4 is 16, times 4 is 64. And then if we were to calculate this on a calculator or look at one of our charts, we would find that the answer to this is 4, okay, positive 4. If, however, we take the cube root of negative 4 cubed, then that is the cube root of negative 64. And if we did that on a calculator or looked on one of our charts, we would find that the answer is negative 4. Okay, so if you have an odd root, your solution can be positive or it can be negative. Okay, notice that that whatever is in here is what we get out down here. Okay, so we had a positive 4 being cubed and then taking the cube root, and we get a positive 4 out. On this side, we put a negative 4 in, and we got a negative 4 out. The negative 4 was cubed, and then it was cube rooted, and we got to negative 4 again. Okay, so you return back to whatever is inside your root. And the reason is because when you cube this, the negatives don't disappear, right? You have a negative times if you have a negative times a negative times a negative, that's going to be a negative. So you end up with a negative under there. And then when you cube root that, you still end up with your negative. So what this means is that if you have any root that's odd, so if n is an odd number, and then you take it to that same power, you're taking the root of that same power, the answer is going to be a. Okay, so if a is positive, this a is going to be positive. If a is negative, this a is going to be negative. Okay, we're going to simplify this in a chart in just a moment. But that brings us to the question of what about even roots? So on an even root, it's a little bit different because on an even root, the even is going to cancel out any negatives. So if we're taking the fourth root of 5 to the 4th, we could say that's the fourth root of 625, and then if we plug that into a calculator or look up on a chart, we would see that the answer is 5. So just like before, we got the same number out. We had a positive 5 in and a positive 5 out. But let's see what happens when we put a negative in here. Fourth root of negative 5 to the 4th power. That is equivalent to the fourth root of 625, right? Because anything to the 4th power is going to be positive, because we have a negative times a negative times a negative times a negative. That equals a positive. So here we have the fourth root of positive 625, and that is negative 5. That's positive 5. Okay, so here we have a negative root in our radical, but we have a positive root as the answer. They are not the same as in with the odd roots. So what that means is that when you take an odd root, if n is odd, of a to the n, it does not just equal a, okay? Because here we have our a is negative 5, and here our a is positive 5. And so we can't say that that equals a. What we can say is that when n is even, we can say that it is equal to the absolute value of a, right? Here a is positive 5, the absolute value of positive 5 is 5. Here we have negative 5, the absolute value of negative 5 is also 5, so that fits this rule. So let's go ahead and put it more formally in a definition here. For any integer, n is greater than or equal to 2. When n is odd, then n root of a to the n is equal to a. When n is even, the nth root of a to the n is equal to the absolute value of a. Okay, so you have to keep this straight. Okay, highlight this or put a star by it in your notes. This is so important. You have to look at this root and see, is it odd or is it even? If it's odd, then you know you can just use a. If it's even, then you have to use the absolute value of a. We must use the absolute value signs when we take an even root of an expression with a variable in the radical. Okay, now there are some cases where you do that and then you decide later that you can get rid of those absolute value signs. We'll look at some of those in just a moment, but always start out by putting the absolute value signs when dealing with an even root. So let's do some examples and see what this looks like. So we have simplify the square root of x squared. Okay, the square root of x squared. So let me rewrite our rules here. So if we have n, the nth root of a to the n is equal to a if n is odd, and the nth root of a to the n is equal to the absolute value of a if n is even. Okay, so just to have that there to remind us of what our rules were on the previous page. Okay, so here we're taking a square root. Now we obviously don't have a 2 there, but we know that that symbol means it's like there's a 2 there. We just take by definition that that means square root. Okay, so if we have the square root of x squared, okay, so our exponent and our root are the same, then we know that it's even, so our answer is going to be the absolute value of a. Whatever is in there, it's the absolute value of that. So we know that this is the absolute value of x. Let's look at b. Cube root of n cubed. Okay, we have cube root, which means our n is odd. So that means that the answer is going to be just a itself, whatever is inside our radical. In this case, it's n. We don't have to deal with the absolute value sign because whatever is in there, that's what it's going to be. C, we have a fourth root. That is even, so we're dealing with this rule. Okay, so the fourth root of p to the fourth is equal to the absolute value of p. And on the bottom, fifth root of y to the fifth, 5 is odd. Therefore, the fifth root of y to the fifth is equal to y. Okay, so those are the rules. Always ask yourself, is it even or odd? Am I dealing with if I'm dealing with an even, I need to take the absolute value. If I'm dealing with an odd, then I can just leave it alone and just use that variable. So let's see if you understood this. Go ahead and pause the video and refer back to those notes of what the rules are. See if you get them right when you come back. So let's go over these. The first one, we are dealing with a not a positive, it is a positive. We're dealing with an even root here. We have the square root of b squared. Okay, so when we're dealing with an even, do we just take the a or do we take the absolute value of a? When it's even, we have to take the absolute value. So the answer to this is absolute value of b. Okay, cubed, that's odd, which means the answer is just the w. Fourth root of m to the fourth, that is even, so we have to do the absolute value. Absolute value of m is the answer. Fifth root is odd, which means the answer is just whatever variable is in here. So the fifth root of q to the fifth is q. Okay, check your answers, make sure they align with mine. So what about square roots of higher powers of variables? So what if we need to take the square root of something, but there's a higher power inside the radical. It's not just a square root of something squared. Well, we need to remember the power property of exponents. And so what the power property of exponents says is that a to the m times n is equal to a to the m all to the n power. Okay, so we can divide up exponents in order to get a desired exponent here. Okay, so let's look at what this means as an example, because I know you're thinking, how is that related? Let's look at an example. Simplify the square root of x to the 6th and the square root of y to the 16th. Now remember, our rules for even, so we're dealing with an even root here, our rules say that the square root of a squared is equal to the absolute value of a. Okay, so but that's assuming that you have a square root and a square here. Here we have a square root, but we don't have a square here. So we need to force a square out of here. So what we're going to do is we're going to use that power, power principle in order to get a square. So remember, we have a to the m times n is equal to a to the m to the n power. Okay, so let's go ahead and use that to our advantage here. So we're going to say that the square root of x to the 6 is equal to, and we're going to come up with an equal expression, but we want a square in there, right? In order to solve this, we're taking the square root, we want to have something squared inside. So if we take x to the 6, but we separate it into x to the 3rd and take that to the square power, then we have our square root of something squared. Let me go back and rewrite this a different way for some of you who may not be completely following what I just did there. So if you can go directly to that step that I just did, awesome. But if not, this step may help you. You can say the square root of x to the 3 times 2, right? 6, x to the 6 is equal to 3 times 2. And then from there, we can apply this rule, the square root of x to the 3 squared. Okay, so that's how I got there. If you need to go through this step, then go through that step, write it out. Okay, so now we're taking the square root of something squared. When we do that, we know we just take the absolute value of whatever is squared. So we're going to take the absolute value of everything that is squared, x third. Okay, and that's how you do that. So let's do it with y to the 16th. So I'm going to rewrite this as y to the what times 2? I want to get something times 2 because I want to have it squared. So that would be 8 times 2. Okay, then I can rewrite that as y to the 8 squared. Okay, so now I've got it in the form I want. I have the square root of something squared, square root of something squared. And I know then that I'm going to have the absolute value of whatever I'm squaring in that square root. So y to the 8th. Y to the 8th. Absolute value of y to the 8th. Now, here I can simplify this even further, right? Because this is even, no matter what goes in for y, the answer is going to be positive. If we put a positive value in for y, it's going to be a positive. If we put a negative value in for y, the answer is going to be positive because you have an even power though. So we can get rid of those absolute value bars there. Here we have to leave them, right? Because if we put a negative in for x, then that answer is still going to be negative. Because you have 3 negatives, that leads to a negative, but 8 negatives leads to a positive. So regardless of whether you put a positive or a negative in here, it's going to be positive. You can get rid of the absolute value bars. So inside your absolute value bars, if you have an even exponent, you can get rid of them. If you have an odd exponent, you have to leave them. Okay, go ahead and try these try-it problems and then come back and see if you did them correctly. So square root of y to the 18. Okay, so we want to get this into the square root of y to the something squared. So that would be y to the 9th squared. And then because we are dealing with square root, which is even, we need to have the absolute value of y to the 9th. Okay. And then because this is odd, we're going to leave those absolute value bars there. Square root of z to the 12th. Square root of z, and then I want this squared, but what do I need to put inside? Well, 6 times 2 is 12, so I need the 6. So that gives us the absolute value of z to the 6th. And then no matter what I put in here for z, it's going to be positive because I have an even exponent here. So then I can get rid of those absolute value bars, z to the 6th. Okay, and those are my solutions. Let's try another one now. So before we just did square roots, let's apply it to cube roots and fourth roots. So we're going to follow the same exact procedure. Okay, we want to get something in here to be cubed because we're taking a cube root. We need to get something in here to be cubed. So, oops, sorry. So we're going to rewrite this as the cube root of y. What times 3 equals 18? 6 times 3 is equal to 18. Okay, so we can rewrite it that way. And then cube root of y to the 6th cubed. Okay, so now I'm taking the cube root of something cubed. And so because we're dealing with odd, then I know that the answer is just going to be a itself. I don't need the absolute value. So the answer is whatever is in here for a, y to the 6th. Here we have the fourth root. So I want to take the fourth root of z to the something times 4. And in this case, we have an 8, so it's going to be 2 times 4. Okay, and then I'm going to rewrite that as the fourth root of z squared to the 4th power. Like I said, if you can skip this step, go for it. Okay, so I'm taking the fourth root of something to the 4th power. That something is z squared, so my answer is z squared. Okay, so you're going to try some of these higher ones on your own. So here we're taking the 5th root, and here we're taking the 6th root. Pause the video, work these out, and come back and see if you got them correct. So for the 5th root of c to the 20th power, we're going to take the 5th root of c to the 4 times 5, and that's going to be the 5th root of c to the 4th to the 5th power. Now I'm taking the 5th root of something to the 5th power, and this is odd, so if it's odd I do not need to worry about the absolute value, so the answer is c to the 4th power. 6th root of d to the 4 times 6 is equal to the 6th root of d to the 4th to the 6th power. Now I have the 6th root of the 6th power of d to the 4th. It's even, so I need to put my absolute value bars, absolute value of d to the 4th. But then I need to look, do I actually need those absolute value bars? I don't, because I have an even power here. Okay? Remember, even powers would get rid of any negatives that are in the d. So we can just put d to the 4th power. Okay, check the answers that you got and see if they match mine before going on. So what if we have coefficients inside our radicals? Okay, so we don't just have variables with exponents. Now we have coefficients. So that means we have numbers in front of our variables. So here we have a 16. So there are a few ways that you can look at this. The first way is you can break it up into factors. So we're going to say, you could say the square root of 16 times the square root of r to the 22. Okay. Now, these are both pieces that you've seen before. You've seen the square root of 16 before, and you've seen the square root of r to the 22 before. So let's go ahead and simplify those. You can either say, you know that the square root of 16 is 4, or you can rewrite it as the square root of 4 squared to get it in that square root of a square format. Either way. And then this one we want to rewrite with an exponent of 2. Square root of r to the 11th squared. Okay, and then so we know that the square root of something squared, this is going to be 4. When you have just a number, you don't need to deal with the absolute value bars because we have the number right there. We know it's positive. It can't be negative. But here, because we're taking the even root and we don't know if r is positive or negative, we need those absolute value bars. So we have 4 times the absolute value of r to the 11th. And then because the exponent inside the absolute value is odd, we're going to leave the absolute value bars there. So this is the solution. This is the answer to square root of 16r to the 22nd power. Let's do this one down here. So we can split those apart. We can say the square root of 25 times the square root of u to the 8. And I know that the square root of 25 is 5, so I'm going to go ahead and simplify that. And then I'm going to rewrite the square root of u to the 8 as the square root of u to the 4th squared. So now I'm taking the square root of something squared, and I know that that's going to be 5 absolute value of u to the 4th. But because this is even, it's going to get rid of any negatives that are in there, so I can rewrite this as 5 u to the 4th. I don't need those absolute value bars anymore. Okay, so let's look at an example. So this one has a coefficient in front of your variable. Square root of 16n squared. Like I said, we can rewrite that as the square root of 16 times the square root of n squared. Square root of 16 is 4. And then the square root of n squared is the absolute value of n. And because our exponent here is 1, it's an understood 1, we don't actually write it, and 1 is odd, we have to leave those absolute value bars there. Make sure you make your absolute value bars clear that they are absolute value bars and they don't look like ones. Make sure that they extend above and below all your numbers and variables. Okay, let's do the next one. So this negative is on the outside, so we just transfer that over and we leave it there. Square root of 81 times the square root of c squared. And that equals, the square root of 81 is 9. And then we're taking an even root, so we need the absolute value of c. Negative 9 times the absolute value of c, and that is the answer for that one. Okay, time for you to try it on your own with a coefficient. Pause the video and then come back and check. So let's go ahead and split this up as the square root of 64 times the square root of x squared. Square root of 64 is 8. 8 times 8 is 64. Now we're taking the square root of x squared, which means it's the absolute value of x because it is an even root. So we need that absolute value there. Okay, let's rewrite this as negative square root of 100 times the square root of p squared. The negative just keeps carrying over, and the square root of 100 is 10. Remember, you don't need an absolute value for when it's a number. You just you only need the absolute value when you have a variable. Now the square root of p squared, absolute value of p, and that's your answer for that one. So check your answers against mine and make sure they match. Let's look at some higher roots. So now we're past square root and we're doing cube root and fourth root. We do it the same way as we do with the square root, but with cubed and fourth roots. So in this one, we can rewrite it as the cube root of 64 times the cube root of p to the 6th. Okay, the cube root of 64 is 16, nope, 4 times 4, it's 4. 4 times 4 is 16, yeah, so it's 4. Okay, so the cube root of 64 is 4. And then I'm going to rewrite this as the cube root of p squared cubed, right? I want to get the same number as an exponent inside as I have of the root that I'm taking. Okay, we're taking an odd root, so we don't need to deal with the absolute value bars. So we know that this is 4 times p squared. 4 times p squared. Let's look at this one. Fourth root. So we're taking the fourth root of 16 times the 4th root of q to the 12th. 4th root of 16 is equal to 2. And then I want to rewrite this so that it has an exponent of 4 on it because I'm taking the 4th root. 4th root of q cubed to the 4th power. Okay, so now I'm taking the 4th root of something to the 4th power, and it's an even one. That means I need to use my absolute value bars. So 2 times the absolute value of q cubed. And because this is cubed, this is odd, we're going to leave those absolute value bars there. That's how you do higher root. Same way as you do square root, just with a higher root. Okay, so now you're going to do some try it problems. Pause the video and come back when you are finished. So let's go ahead and rewrite these as the cube root of 27 times the cube root of x to the 27. Okay, cube root of 27 is 3. This is where it comes in really handy to have some of those lower powers and roots memorized. And then we're going to multiply that times the cube root of x, and I want to get a power of 3 here, so I need to divide out a 3. So I'm going to do x to the 9th to the 3rd power. So now I'm taking the cube root of something cubed, and that's 3. Now we're dealing with odd, so absolute value of x to the 9th and absolute value, and that's my answer. 4th root, let's rewrite it as the 4th root of 81 times the 4th root of q to the 28. 4th root of 81 is 3. And then I need to rewrite this with a power to the 4. 4th root of q to the 7th to the 4th power. Now I've got my 4th power and my 4th root. It's even, so I'm going to use the absolute value. 3 times the absolute value of q to the 7th power. Okay, and because this is, sorry, this one was odd. We didn't need those absolute value bars. That's the point. Sorry, that's the point in the class where someone would have said, Mrs. Clark, you don't need those. And I meant to just erase my last step, and I instead erased them all. So this one is actually 3 times x to the 9th, and this one was 3 absolute value of q to the 7th. I really miss having you guys there to correct my mistakes when I make them. Okay, so check your answers. If you need to go back and see my step-by-step work, go ahead and do that. One more concept. What about when there are 2 variables? Okay, you treat it the same. We're still going to break this apart. Oops, sorry. We're still going to break this apart. We're going to say the square root of 36 times the square root of x squared times the square root of y squared. Okay, the square root of 36 is 6. And then if we're taking the square root of something squared, those are even, so we have to take the absolute value of x, and the square root of something squared, that's another absolute value of y. Now we have the 6 times the absolute value of x times the absolute value of y. We can combine the x and the y in one absolute value symbol, so we can get 6 times the absolute value of x, y, and that's the simplified version. Okay, down here, let's break this apart. Square root of 121 times the square root of a to the 6th times the square root of b to the 8th. Okay, so the square root of 121, go back to your 4th grade times tables, 3rd grade times tables, and that would be 11. 11 times 11 is 121. Now we're going to rewrite this with a power of 2 and rewrite this with a power of 2 because we're taking square roots. So that's the square root of a cubed squared, sorry, that's a cubed, that's a 3 in there, times the square root of b to the 4th squared. Okay, so we have 11, and then we're taking the even, so we need the absolute value bars. 11, oh, this is going to look confusing because we have 11 absolute value of a cubed, and this one, absolute value of b to the 4th, and I'm running out of room there. That's absolute value bar. Now, b to the 4th doesn't actually need the absolute value bar because it's to the 4th power. If b is negative, it's going to cancel out, so we can rewrite this as 11 absolute value a to the 3rd and absolute value b to the 4th. And the final one, same thing, you have two variables, but you have a cube root. So let's go ahead and do that. We're going to break this apart. Cube root of 64 times the cube root of p to the 63rd power times the cube root of q to the 9th power. Okay, the cube root of 64 is 4. And then I'm going to rewrite this with an exponent of 3 and rewrite this with an exponent of 3. Cube root of p to the 21 all to the 3rd power. Let's see, I'm going to grab another color here and kind of make a little dividing line so we don't get confused. Okay, and then that's times the cube root of q to the 3rd power to the 3rd power. And then I'm going to come down here so I don't run into the others over there. So I have 4, and we're taking an odd, which means we don't need to worry about absolute value. Okay, so it's p to the 21 and q to the 3. And that's your answer. Okay, one more try it problem and then you are done. Well, one more try it slide. 3 try it problems. So go ahead and pause the video, try these. Notice you have square roots on both of these, so you need to worry about the absolute value. Cube root on this one, don't worry about absolute value. Pause the video, work it out, and then come back. So let's go ahead and do this. We're going to rewrite this as the square root of 100 times the square root of a squared times the square root of b squared. And the square root of 100 is 10. And we're dealing with an even, so we need to use absolute value of a and absolute value of b, but we can combine those absolute values together and get 10 times the absolute value of a, b. Okay, I'm going to do this one like I would normally do it. I'm just going to look at this and know that the square root of 144 is 12. So I'm not even going to pull that out into a square root. And then I'm going to deal with the rest of this. I can deal with this inside one square root. I've been doing it this way just to show you how to pull it all apart, but we can look at this together. P to the 12th, Q to the 20th, and you can actually do it this way. If this way confuses you, don't do it. If this way is better for you, then do it. I'm going to do this. I'm going to say that is equal to P to the 6 times Q to the 10, and that whole thing is squared. Okay, so I pulled it out together. So now I'm taking the square root of all this squared, so I can simplify, and I do need my absolute value bars because we're dealing with an even root. 12 absolute value of p to the 6 q to the 10. Okay, so if you'd rather not pull everything apart like this, take it all piece by piece, that's fine. You can do it this way. If this helps you, then do it that way. Do whichever way is best for you. Okay, now I'm looking at these. I see both of these have even exponents, so any negatives are going to disappear, so I don't actually need those absolute value bars. 12 p to the 6 q to the 10. That's a 10, not a 16, by the way. It's a 10. Okay, and then this last one is a cube root. I'm going to switch color here in case I run into those other ones. Okay, so cube root of 8 is 2, so I'm just going to pull that 2 out, and then I'm taking the cube root of x to the 10th to the 3rd and y to the 4th to the 3rd. So that's going to be 2, and then it's odd, so I don't have to worry about absolute values. 2 times x to the 10th times y to the 4th, and that is your answer. Okay, check over your answers and see if they match mine. If not, go back and watch the explanation again. Check Google Classroom for your assignment, and do not hesitate to reach out with questions.